In this video, I'll show how to train a custom LoRa, or low-rank adaptation, of the open-source Flex.1 alpha model using the ai-toolkit utility running within a Podman container on a Fedora Linux system. I provided links below to get more details on ai-toolkit and the Flex.1 alpha model. Let me start by showing what the end result will be. I'm training a LoRa of my dog, whose name is Apollo. I'll be training the LoRa with 15 input images of Apollo that you can see here. Once I've trained the LoRa, I can use it to generate new images of Apollo. Here's some examples of the images I've created with this LoRa. There's a couple of pictures of Apollo at the beach, Apollo dressed up in a suit, a close-up of his eye, several pictures of Apollo in a field of flowers, pictures of Apollo exploring Mars and the moon, and finally a couple of pictures of Apollo in the mountains and in the snow. Now let's go into details on how this was done. I'm using a Fedora 41 system with an NVIDIA RTX 3090 GPU. To follow this process, you'll need to have the NVIDIA driver and the NVIDIA container toolkit installed and configured for use with Podman so that your Podman container can access the GPU. I have a container file and the commands in a GitHub repository that is linked below. I'll start by cloning this repository onto my system. Let's take a look at the container file. As you can see, it's based on a CentOS Stream 9 base images. Some packages are installed, including Python 3.12. Next, the AI toolkit repository is cloned and installed, and some additional prerequisites are installed with pip, including PyTorch. There's also a config directory that is part of this Git repo that we cloned, and this contains a couple of example configurations from the AI toolkit repository for Flux and Flex models. There is an input directory. This is where we'll place the input images that the LoRa will be trained on, and there is an output directory. This is where the LoRa will be saved to when we're done. Let's start by updating the configuration file. I'm using the open source Flex.1 alpha model in this example, so I'll edit the config file for Flex. Within the config file, I'll update the LoRa name to Apollo LoRa v1. The trigger word is the word you'll use in the prompt when generating the images later on. This should be a unique string of characters, and in this example, I'm just using Apollo spelled backwards, which seem to work well. I'll update the max step saves to keep to 18. I'll explain this more in a minute. The folder path needs to be set to /ai-toolkit/input, as this is where we'll be configuring a volume mount for the container later on. I'll configure the steps to 5,000. Notice that the sample every setting above this defaults to 250, which means a LoRa will be created every 250 steps. And we previously set that max step saves to keep to 18. So when this is all completed, we'll have 18 intermediate LoRas, and these will be created every 250 steps between steps 500 and 5,000. This will give me a lot of options to try out, and later on I can just delete the ones that don't work well. In this example, the LoRa I ended up going with was the one at 4,000 steps. The last thing I'll change in the configuration file is the prompts setting near the bottom. Every 250 steps, the AI toolkit will generate images using these prompts so you can monitor the status. I'm going to delete all the default prompts and just have a single one that is the trigger word followed by dog walking in the grass. These images will be saved in the output directory under the samples subdirectory. Jumping ahead after this is all done, this is what you'll see in that samples directory after I've trained the LoRa. The last part of the file name is the step number, and you can see around the 2000 step mark is when the output actually started to resemble Apollo. Okay, we're done with that configuration file. Next, I'm going to go grab the 15 input images of Apollo and then copy them into the input directory from the GitHub repo that I had originally cloned. Next, I'll use the podman build command to build the container image, tagging it with the name ai-toolkit. This will take a few minutes, so I'll go ahead and speed up the video here. Okay, once the container is built, I'll go ahead and run the container with the podman run command and specify the Flex configuration file that I had previously configured. This will first download the models that are needed, and then it will begin training the LoRa. This took about 5 hours using my NVIDIA RTX 3090. Let's fast forward to about halfway through, and you can see that it will display the current step number, the elapsed time, and the estimated time remaining. And once this process completes, we can take a look at the output directory, which will contain 19 LoRas at the various steps, ranging from step 500 through 5,000 every 250 steps. From there, I can use something like Comfy UI to generate images using these various options for the LoRa and experiment with which one produces the best result. I'll cover how to run Comfy UI in a Podman container in a future video. Well, thanks for watching and have a great rest of your day.